All right. Ooh. Well, all right. 1 minute late, but that's so welcome back. Today is February 2nd. Is this Groundhog Day? I feel like it's Groundhog Day. I don't know. Um, so yeah, we did test one obviously last week. Just out of curiosity, right? So we do offer for you to write it on paper. So who here that wrote it electronically would prefer to write it on paper for the next one? No? All right, that's good. Good, I'm glad. I think it offers a lot more. At the worst case, I mean, you can still technically, even if it doesn't run, you can still technically get perfect on test one, right? Because if it doesn't run, we just mark it as a paper. Um, so, and the advantage is, of course, if it doesn't run, well, then you can maybe track down an error that you made and fix it. Yeah, we will. I realized there was a lot of, particularly at the end of class, there was a lot of commotion here. We will try to improve that process for next time. But yeah, technically, assignment one, the TAs are working on assignment one. I might move them to test one. I'm guessing most of you would be more interested in your test one mark. At least the last class was. So I'm thinking of, we'll maybe shift the TAs to work on test one and then assignment one they can mark later. I mean, technically you should know 3/4 of your assignment one mark, right? When you run the script, you see what your mark is. So yeah, we might try to get the TAs to move on that. Otherwise this week, tutorial 3 is due. It's just, we're gonna actually talk about today with, well, it's about arrays and what they contain. So arrays of objects, arrays of pointers, arrays of objects on the heap, arrays of objects on the stack. Yeah, we'll get to that today. And then next week is, well, technically nothing is due. I know you guys have a lot of midterms that week. Don't forget about assignment 2. All right. Technically, you should be working on assignment 2 like this week and next week. I'm not allowed to make anything due from like Saturday to Sunday on the reading week. Right, that's your time to relax. But it's also, the TAs are not obligated to answer your questions during that time, right? So I'll be here, that's fine, you can ask me questions. But the TAs may be busy, so just keep that in mind. All right, questions? Okay. Last class we were talking about dynamic memory. So for assignment 1, sorry, let me refresh this a little bit. Well, we were talking about, in assignment 1, everything was statically allocated, which made our job easier because we didn't have to worry about memory at all. But now, right, we didn't try it, but technically if you like doubled the size of the array in home share on assignment 1, you would crash the program, I believe, right? So at least in assignments past, maybe more than double, I don't know. But you're very close to the limit of how much stuff you could put on the stack for assignment 1. So for assignment 2, we're going to be putting more stuff on the heap, which is a lot easier to put large data structures on and not crash your program. So that's what we were talking about. And of course, when you're putting stuff on the heap, now we're going to use pointers a lot more, right? Because, well, it's some piece of memory way off out there, and I need to know the address of it because I don't have direct access to it. And so we're going to store those in pointers. Where did we leave off? Oh, yes. So now that we're putting a lot more stuff on the heap, we have to worry about memory leaks. So what is a memory leak? A memory leak is basically I put something on the heap, I have a pointer to it initially, but then somehow I lose that pointer. So that's a memory leak, and that means that that piece of memory, I can no longer delete it, I can no longer access it or change it. It's completely useless until my program ends, right? So I can't use it, other programs can't use it, it's just gone. So we want to avoid that whenever possible. We are C section. Well, so what are some common ways we can leak memory? Well, of course, all memory leaks happen because we lose a reference. Basically, we have an address and we lose that address. So, well, one way to do it is to sort of misunderstand how your pointers are being used. So if we go down to memory leak 2, right, so I declare a pointer, P1, I assign it null or null pointer. These are good practices, equivalent as far as we are concerned. I pass P1 into memory leak 2. Now I passed in this pointer. I assign it a new int on the heap. I print out the value, which should print out 87, and then I return. And then up here, I call delete, right? So the question is, yeah. Yes. To use reference, like to pass a pointer by reference kind of thing? Yep. Sorry? Exactly, yes. There's actually a couple ways we can do it. So yeah, that's very astute. So problem solved, there is a memory leak here because technically I'm passing, you could, we've used this in the past to pass integers by reference, right? So passing by reference by pointer. But now I actually don't want to pass an int, I want to pass a pointer. And if I want to use it as an output parameter, I have to pass the pointer by reference. So you would want to do something like this or this. But as written, this is technically a memory leak, right? Because I call new here. When I call delete here, this is not pointing to that. So when I call memory leak 2, I copy the contents of P1 into I1. The contents of P1 is null pointer. So I1 is a separate pointer that points to null pointer. I assign it a new piece of memory, and then I never delete it, right? So technically, this is a memory leak. I will, I suppose, prove it to you in a second. All right, so it runs fine, nothing wrong there, but when I run it with Valgrind, yeah. My leak summaries, I definitely lost 4 bytes in one block. 4 bytes is, of course, the size of an int, and I never actually deleted that. Incidentally, as you can maybe surmise, it is safe to call delete on a pointer that points to null pointer, right? So that's okay. It's not going to, your program won't crash. And I guess it is like, if you're not sure if you should delete this, then maybe it's like, well, as long, yeah, well, I don't know. You can figure out if this is something you would want to use. I think if you delete something, you should definitely know if it's a pointer to some valid memory or not. But right, and technically in the real world, you're going to use smart pointers anyway, so maybe this will never come up. But just in case it does, this is perfectly fine. Yeah, here's another version of a memory leak, right? So I make a new int. I return, well, I don't actually return the pointer. I return the value that it's pointing to, right? So I return a dereferenced pointer. It returns an int. And then, so if I did something like this, right? Well, I don't have any pointer here that I can call delete on, right? So these are just 2 examples of ways I can lose pointers. Anyway, Questions? Okay. So that leaves us with, well, how do we make sure that we don't leak memory? So for C++, it's always a good idea to have a memory strategy up front. Right? There are multiple memory strategies. We're going to teach you a popular one. Just because it's popular doesn't mean it's right in every context, but it's good for the size of programs we're doing. So this resource acquisition is initialization. Why those particular words in that order, I have no idea. What it means is that when I allocate dynamic memory, I'm going to tie it to the destructor of a statically allocated object. Right? So we saw in assignment 1, we don't have to delete anything that is statically allocated. All of that happens automatically. So now the idea is we're going to tie these things that we have to delete to these things that automatically get deleted, and then we don't have to worry about it. Right? So that's the idea. We're going to see how that looks in practice today. There are, of course, and yeah, so a good rule of thumb also, wherever I create an object, that's probably where I want to delete it, right? So if I create an object in the constructor of a class, I probably want to delete it in the destructor of that same class. If I create an object in an add function, then I want to delete in the remove function. These are good rules of thumb to follow. We'll come back to that. So yeah, sure, let's write this out. So we saw for assignment 1, we did this home share application, right? And so this home share object contained a bunch of rentals, and these rentals contained a bunch of reservations. And everything was statically allocated, so we didn't really have to worry about what deleted what. But now we're going to put all of these things on the heap. And so what's going to happen is that, well, basically, we want to make sure that home share gets deleted. And when home share gets deleted, well, home share is going to go through and delete all of the rentals. And then each of those rentals, they contain a bunch of reservations, so they will delete their own reservations. So then I don't have to worry about deleting every single individual object. I just delete the main sort of master object, and it goes and makes sure, we just get like a domino effect of things that delete one another. So that's sort of the pattern that we're going to use for assignments. Now you don't have to use this pattern. You can do whatever you like, as long as it works, right? So as long as you correctly manage memory, you're free to do whatever. This is just a suggested way. Yeah, so the key takeaway here is that you should plan out memory management in a C++ application. You shouldn't just sort of like cowboy it, like just, oh, I'll just allocate it here and I'll figure it out later. Like that's a bad idea. And in fact, even with memory helpers like garbage collection, right? If you write, I don't know if you can still write Android games in Java or if it's all Kotlin or whatever. But once upon a time, you could write Android games in Java. And Java, of course, has a garbage collector. And so one of the things you would have to do to make sure your game ran correctly is you never dereference anything in the game loop, right? So before the game starts, you call new on a bunch of stuff. You run the game, you make sure nothing goes out of scope, because if it does, then the garbage collector will run. And if the garbage collector runs, your game slows down. Right? It'll stutter. So even on languages that have memory management, if you want them to run efficiently, you should understand what's happening. All right, so we're going to start with a simple example. Yeah, so recall before we had the example with the calendar and the dates, right? Where the dates now have this extra event member variable. So basically, it's I add something to my Google Calendar. Now this is a very low-tech version of that where I run it from the command line. So I can add events on dates, and then ask the calendar to print out everything, and it tells me all the upcoming events. All right, so we did that with statically allocated dates. Now we're going to do it with dynamically allocated dates. So if we look at our calendar class, we have the same functions. Well, this might be new, but add event and remove event are the same. Print is the same. Now we're going to use a statically allocated array of pointers. This is still not the best, but one step at a time. So right, so this is a statically allocated array, but now it's an array of date pointers instead of dates. So we're going to save some memory there. Date pointers are 8 bytes. Dates are, I think, 12, or maybe, I think they're 12. And then, of course, we still want this numDates member variable. Now in our constructor, I still want to make sure I initialize this, right? There's a lot of people on the test who forgot that, and then when they go to print out all of the stuff, of course, num, not necessarily numDates, but whatever they called the variable, was some random number, right? Possibly in the millions or billions. And so they would be printing out a lot of stuff. So you always remember to initialize your member variables. Nothing we have to delete here yet. Let's look at this add event function. All right, so now the same thing as before. Again, I'm not going to add things in. I should be adding dates in order as defined by their less than function. I'm just going to add them to the back. We've already went through how to do the adding them in order thing. So I'm just going to add them to the back because that will be sufficient to test. Of course, the first thing I always have to do is make sure I have room. So I'm going to do a bounds check. Right? So I don't want to make any new dates, especially if there's no space here, because then I would just have to delete them after anyway. Now that I know there's space, well, I'm going to make a date. I'm going to use a date pointer and a call to new to put it on the heap. Okay. And then I'm just going to add this to the back of the array, right? So it's an array of date pointers. So, and the back, technically the next empty location is at numDates. I want to increment that and then return true. All right, good. Easy enough. Questions? All right, so no different other than this single call to new here. It's going to lead to a few things we have to take care of, but let's make sure that they all print. So that we can test it out. Now dates, well, this is an array of pointers, which means that I no longer use the dot operator. I'm going to use the arrow operator. Otherwise, I'm just going to print them all out. This should be enough to run a test. Yeah, so you are thinking in the correct direction. So I've said new here, and there's no corresponding delete. So now I have to consider where to delete stuff. So yeah, we're going to get to that. First, we're just going to make sure everything works. Because yeah, you never know. All right, so those are just date classes. I believe, well, I think we went over something similar to that. So I'm not going to do the remove because the remove is not implemented, but I'm going to statically allocate a calendar. I'm going to call add event 3 times, which should make 3 dates, and add them to my calendar, and then I'm going to print them out and make sure everything works. And then we will start to properly manage our memory. Okay, statically allocating a calendar which contains dynamic memory. I print all the events, so everything's working, but if I run it with Valgrind, of course, I've never called delete. You don't see any deletes, so of course I lost 144 bytes in 3 blocks. That's a lot of bytes. I guess the strings are quite a few. All right, so where do we delete these things? Well, obviously, the first place we should delete them is, well, I have a call to add event that says new date. So my symmetric call to remove should delete them, right? That sort of makes sense. So let's write the remove function. So to start with, I'm just going to search for this date that corresponds to the event. So if, and for this now I want to look at my date class and see how I'm going to find that. Well, we've defined it equals that takes a string and compares it to the event. Okay, so that's what we're going to use. A getter would have worked just as well, right? So get event, and then I could have compared it directly to the event in the calendar class. We sort of use both of those patterns here. But so dates equals event. So if this is the event that we're looking for, well, then, well, the first thing we should do is probably delete it, right? So again, a call to new here means a call to delete here as a rule of thumb. So I'm going to delete that date. And now I want to cover it up, right? So if we look back here, so again, let's look at what the process is for remove. We've done this with add. But let's say I call remove C. Well, what should happen? Well, first we go through and we search for C. So we say, is A equal to C? No. Is B equal to C? No. Is C equal to C? Yes. All right. So what do we want to have happen? Well, we want to delete C first of all, but this is sort of an abstract representation of what we're doing. So let's not get bogged down into the details. Whether or not we delete C, we want to move D over here, and then we want to move E over here. Right? We want to close that gap and effectively erase C from our array. If I did this the same way I did it for the add function, right? When I did it for the add, I started at the back and I copied that over, and then I copied, I was going the other way with add. But for the add, I started at the back and I worked my way back to the index I was interested in adding, all the while copying things to the right. Here, if I started at the back, well, then I would copy E over here, and that would overwrite D, and then I would copy E over here, and that would overwrite C, and then whatever was last in my list would be replicated up to the thing I wanted to delete. So in your add and remove, although they are similar, you have to be careful of the direction that you're copying things. So I want to start at the index itself, and then I want to copy D over here, and then I want to copy E over here. And then I can leave the old version of E there. It'll get overwritten later. All right, so questions on that? All right, so that's just the overview of what we are doing. So I delete the date, and now it's a pointer that points to a deleted piece of data. I'm just going to overwrite it. I'm going to make another for loop. This may or may not be exactly correct. We'll work out the plus minus one after. Plus plus J. And then I want to say dates at J equals dates at j plus 1. So that's it. That's going to go through and shift everything. And then once I'm done all of that, I'm going to return true. All right. Questions? Is this going to work, do you think? Did I nail the edge case? So num dates, generally speaking, you might be thinking, well, maybe I should do a +1 or a -1, or this will work for a long time, but it's not quite correct, right? It'll work until my array completely fills up. But if I look at what the maximum value of j is equal to num dates minus 1 at most, at which point I copy from num dates. Num dates is empty technically. So I'm going to copy some garbage into the next location. It's not going to hurt anything for a long, long time until my array is completely full, and then I'm going to try this and I'm going to get a seg fault. Well, if I'm lucky, or I'll get some weird data. But so yeah, technically I want to do something like this. It should be -1, or I could have decremented num dates first. Just, when you're writing stuff like this, try and think of the edge cases, and that usually helps you figure out what you should write there. All right, questions? I think this will work. Let's try it out. I'm going to remove class. All right. It's not running with Valgrind right away. So I allocated my calendar, I added these 3 events, and then I removed one, and it seems like, yeah, it looks good. Looks good. Of course, there are still, if I run it with Valgrind, I still have memory leaks because, well, I deleted one thing, but there's still 2 things left. Yeah, that's a good question. So for me, it's you write 100 for loops, and then eventually you just remember. But if you were sitting down fresh, how would you recall? I mean, I think often those diagrams the very messy diagrams I make, but I think those are very helpful, like in terms of visualizing what's happening with the memory, right? So if I was going to sit down and write a remove and I wasn't sure what I was doing, I would trace out what happens in a simple example and make sure that all the numbers line up, right? So if I wanted to take extra care here, I would also track the num dates or whatever. So initially this was set to 5. And then you can keep track of, all of the things that are supposed to happen. So yeah, that's what I would do, is draw a lot of pictures. Yeah, hopefully that answers your question. Other questions? Okay. Well, I still haven't deleted everything, but you may have noticed there's fewer things that leaked. Of course, the last thing is I want to delete in the destructor. So yeah. Well, simple enough. Simple for loop. Now dates at I is a pointer, and I can legally call delete on any pointer, so this is good syntax. Of course, now once this runs, my calendar is completely wrecked, right? Because now I have an array full of stuff that points to deleted stuff. But I don't care because this is my destructor, so this means As soon as this runs, well, the next thing that gets deleted is the array itself. So I don't have to worry about the fact that I'm sort of, I'm not calling the remove function, which closes all the gaps. I don't care about that. I don't have to be careful. I just delete everything, and then it all gets cleaned up. All right, so if we try to run this now, well, let's just run it first. All right, no double freeze, no seg faults. It's a very good sign. If I run it with Valgrind, all heap blocks were freed, no leaks were possible. Okay. So the things that we did that, again, these are suggestions. You can do whatever you like, but if I call new in add, then I probably want to call delete and remove. That makes sense. There are exceptions, but not in this case. But also, if I'm not removing every event, then I should clean up the rest of my destructor, right? So in general, for every call to new, there is a call to delete, whether it happens here or here. But that's our strategy. It's going to get a little complicated because we're going to use collection classes, but questions? All right. So we're going to talk a little bit about double pointers. So one thing that does come up, now I'm not a big fan of double pointers. I think they are, once you get used to them, they're like anything else, right? Once you're used to them, they're no problem whatsoever. But in the beginning, they are kind of messy to work with. But you can do the same thing with a getter, so I don't really like them in that respect. But if you're working on like old C++ code, you might see double pointers. So we're going to go over what a double pointer is and does. Also, we use double pointers for arrays, so it's a good thing to kind of understand them. But let's say that I declare an int I equals 42. Well, then let's keep track. This is a variable called I. It has a type of int. Its value is 42, and its memory location is this hexadecimal value A8. All right, and let's say I do this I pointer, and now I pointer wants the address of an int, so that's what I'll give it. So now this gets the value A8, and so this is called I pointer. It is a type int star. Its value is A8, and its location is AC. Well, now I can also declare this double pointer type. And of course, a double pointer takes the address of a pointer. So I am going to take the address of I pointer. And so the address of I pointer is AC, so that will be the value. And so in our chart, double pointer, the type is int star star. Sorry, if I touch the screen, I get a bunch of artifacts, but if I don't touch the screen, it's super messy. Int star star. Its value is AC, and its location is B3. Okay, so now what can we do with this double pointer? Well, what if we printed it out to the screen? If we print out double pointer, this will of course print out the value, which is AC. So we'll get a memory address AC. Well, it'll technically look like this. And there'll be a lot more, of course, characters there, but yeah, that's what you would get. If I dereference my double pointer, well, then it jumps to this address, AC, and returns the value it finds there, which is A8. So if I dereference that, I would get this value written out. If I dereference this twice, well, then it's going to jump twice. So first it jumps to here, and then it jumps to this location A8, which is over here, and returns the value it finds there. So here it would print out 42. Right, so double pointer is it's kind of straightforward in its implementation. Now they're tricky to use, of course, because you have to keep track of all this stuff in your head. But that's the basics of it. Questions? Okay. So we're going to quickly go over an example of using a double pointer that you might actually find in the wild. Because once upon a time, they were used a lot more frequently. So in my calendar class, I have this get event function that returns a pointer. Very straightforward, right? Nice getter. I understand this perfectly. I pass in this event. It finds the corresponding event, returns that pointer. Did I implement it? No, but I could very easily. I'm just going to look at everything, and if something matches, I return it. So if date set I equals event, return date set I. Otherwise, I return null pointer. So there we go. Nice simple getter. Like not really a getter, but like a get event. I either return an address or I return null pointer. On the other end, I should check when I call get event that if it's a null pointer, then of course I don't want to try calling print on it or something like that. But I can do basic, I've sent back the thing and or a message that this thing is not viable. We're going to do the same thing now with a double pointer. So in other words, we're using an output parameter instead of a getter. So now I want to pass in a pointer by reference. So I want to go to this example. So get event, here's the similar get event, but now I return a Boolean, right? I'm going to return true if this pointer is valid and false otherwise. We talked earlier about passing a pointer by reference, which is actually a good way to do this. So this is actually what we're doing, but we're doing it with a pointer because maybe not so much in C++, but in C, you're going to see stuff like this. All right, so let's go through it. If I wanted to implement this get event, well, I have the same for loop. I can actually steal some of this logic. Right, I'm going to do the same check. The way that I return the date will be different. So this, I don't want to return the date. I want to return true. But first, I want to assign this pointer to my output parameter here. Okay, so what do I want to do? I dereference a date. If I dereference a double pointer, I get back a single pointer. And then I can assign that the pointer that I want to return to that the pointer that I passed in by reference. Now, if you don't understand it, that's perfectly fine. You're exactly probably where everybody is the first time they see this. Like I said, it's not a great pattern. I prefer, like it's a get, why don't you just use a getter? I mean, why don't you just use a return value? That makes more sense to me. But legacy code, you might see something like this. How do I call it now? Because calling it is actually different as well. So I made a calendar. I added 3 events. I want to get one of those dates. I'm going to use a double pointer. Well, first, this is my date I want to get. And I'm going to pass it in by reference. So cal.getEvent. So let's get the event y2k, and I want to pass in toGet, but I'm passing in by reference, so I need the address. And really, this returns a Boolean, so I should sort of check to make sure this is valid. Or all right. So there you have it, getting the Y2K event using a double pointer, and it worked. All right, so a lot of trouble for something that you could easily solve with a return value. But the pattern is, and this is important because where a lot of you, like if I ask this on a final exam, right? So this could come up, is the tendency is to do this and this. Right, of course, now my to-get print, I have to, this is a double pointer, so I have to dereference it. Syntactically, this is all valid, but when I run it, I get a seg fault, right? So does anybody understand what happened there? Probably not. That's okay. This is complicated. But basically, I'm passing in, if I pass in the address of a pointer, when I dereference it, I get back a pointer. If I just pass in a double pointer that's pointing to nothing, then when I dereference it, I get back nothing, right? I get back whatever garbage is there. So I get a seg fault. Yeah. So this is the correct pattern for that. Anyway, it's hard. If you don't understand it, that's fine. You can always work through it yourself. I think it's not as big a deal these days because, you can always have this corrected instantly by a large language model, but questions? Okay. But it is kind of important to understand double pointers because we are going to use them with our arrays. So we're going to dynamically allocate some arrays now. So everything we've seen so far, we've seen two main patterns, and we're going to add two more to that. So our arrays now, we've only had them on the stack, but we're going to put some of them on the heap, right? And then when they're on the heap, you can either have an array of objects, the same as we did before, or an array of pointers. So yeah, that means we're going to have 4 different ways of storing data and arrays together. All right, so let's take a look at those. And this is, right, if you're having trouble with your tutorial 3, this is basically what we're asking for, is a bunch of examples of this, along with, we're trying to help you understand the difference between a copy constructor and an assignment operator. But the first thing we're going to do is a statically allocated array of objects, which is what we did on the assignment and on the test. So it looks something like this. I have my main stack frame. And then I'm going to statically allocate an array, and each array location will contain a date object, and the constructors will get called when I construct it, and everything will get destroyed for me. I don't have to do anything. That's going to be the first pattern. That's what we should be kind of familiar with that. So the declaration, I declare an array, and it's of type date. And so when I call this, I should get calls to the default constructor. And then I'm going to print them out, and then I'm going to set the dates and print them again. And oh, All right, so when I declare the array, of course, the constructors are called twice. I got some default dates. And then I set these default dates to be these other values, and I printed them again. And then when I exited, these dates were destroyed along with the array. I didn't have to do anything. Everything's statically allocated. All memory is handled for me. You've seen this before, but questions? Okay. Well, let's look at what if we did something similar, but now we're going to use pointers. So in terms of our model now, again, we have a main function on the stack frame. Again, we have a statically allocated array, but this time it's pointers. And so on the heap, what we're going to do is we're going to make a new date. And I'm going to assign this to point to it. And then we're going to make a second date, and we're going to point to that. Now these dates on the heap we have to handle. We have to delete them, right? This is basically the pattern that we just implemented in the calendar class. So the way we declare it, well, this means we're declaring a statically allocated array. The type is of date pointers. We can declare a date pointer, give it a value, and then copy that pointer into our array. Or we can just simply make a new date that returns a pointer. We can assign it directly into our array. And then we can print these dates out. And we'll come back to this part. So I allocated the pointers, and then I made two date objects. The constructors were called. At no point are the destructors called, because I have to do that automatically. So that means I have a memory leak here. Or sorry, I have to do that manually. So now I'm going to manually delete these two things. And when I delete them, the destructors are called. So technically, I should be able to run this with valgrind and no memory leaks. All right, so 2 calls to new, 2 calls to delete. Questions? All right. So now the third and fourth examples, we're going to do something a little bit different. So in my main function, I'm going to have a single pointer, and it's going to point to an array on the heap. The array contains 2 date objects. All right, so I'm going to have to call new to make this array, but the date objects, they will have their default constructor called on them, right? Because they're just the way I'm going to construct it. So a dynamically allocated array of objects is here. Now I have to declare a pointer, right? So a dynamically allocated array of objects. The variable that I actually use to reference it is a pointer. In fact, all arrays are pointers technically. I make a new array of type date. So this goes on the heap. And then I can print those right away. And then those will get default values. Whoops, let's do. All right. So when I make the array, the constructors are called on the 2 dates. The array itself is on the heap. I print out the dates. The dates never get destroyed because I didn't delete the array. And if I run this with valgrind, of course, I have memory leaks. So to delete the array, I make this call. Now, these dates are technically statically allocated inside the array. So when the array gets destroyed, right, when their surrounding context is destroyed, those dates get destroyed. So I should see 2 calls to the date destructor. And there we go. After we delete the array, both of these dates get destroyed. And I can run it with valgrind and no memory leaks. Questions? Okay. Finally, so number 4 is I cannot remember if I ask you to do this. This is, of course, the best way to do it, right? I'm going to have a big array of pointers. And so the big array is going to go on the heap where it can be as big as it likes. And I'm going to only assign values. I'm only going to allocate extra memory when I need it. Okay, so if we look at the diagram, it's going to be similar to this, but there's going to be a couple changes. Instead of dates being stored inside my array, these are now pointers to dates that are stored outside the array. Right, so now everything's on the heap, and sort of the most efficient way to handle memory, arguably. To make one of these things, I need a double pointer, because technically the first dereference is this, right? This is the same as a dereference operator, essentially. So I jump to the array, and then I need to dereference it one more time to jump to the date. So to do that, it's a pointer to a pointer, and I need a, or sorry, it's pointer to a pointer to a date, and I need a double pointer. So new date, this puts it on the heap, and this tells us the type. Now, the syntax is exactly the same as any array that's on the stack. I use the subscript operator. It returns a pointer, and then I can assign it a pointer that already exists, or I could assign it a new piece of data. No, I didn't want to do that. So yeah, the two dates are constructed. When I call new, I print them out. I didn't deallocate anything at this point, so no destructors were called. And of course, I have memory leaks. Here, I'm going to delete all three of those things, right? So again, a call to new for the array and two calls to new for dates. And so I have three corresponding calls to delete. And so the destructors are called, and if I run it with valgrind, everything is cleaned up. All right. What do you think happens if I do this? Is this okay? Let's look at the picture. So here I deleted the array before I deleted the dates. So this gets destroyed. And now this is, this pointer is pointing to nothing. And I have nothing that points to these two things. Now, this being C++, you can kind of get away with this sometimes, right? This is technically undefined behavior. If you have like a linter or something, you should be okay, but I have run this in the past on previous versions of the compiler, and it's worked. In this case, I think we'll get a seg fault, but let's see. So yeah, I get a seg fault. If I run it with valgrind, I wonder what happens. Yeah. So valgrind actually manages it for us, even though it complains an awful lot. It did actually, instead of getting a seg fault, it went in and deleted those things. Interesting. But yeah, so this is wrong, of course. You shouldn't do this. It's technically undefined behavior, so getting a seg fault is lucky. Not getting a seg fault, you might get some weird behavior. But yeah, so that's it. Those are all four of your array types and all kind of dynamic memory that you're likely to bump into on your assignments. Questions? Yeah, so all pointers should be deleted first and then delete the array afterwards. All right, let's do, we'll come back to this guy. Sorry, let's do a woo clap, but let's do our woo clap. Oh, I don't have one for C. All right, here we go. It's coming. Try and go a little bit slower so that, but right, you don't get, I mean, try to answer it correctly, but if I'm explaining it and we're coming to the end and we're going to go to the next page, just click anything, right? So you get your participation marks. So we got quite a few people. All right, seems to be mostly leveled off. Okay. All will start off easy. Given the following variable declarations, how would you point our pointer to I? This is just syntax, but it's funny because I can remember the first time I did like assignments in C, like not assignments, but tutorials. Like I had no, pointers were very confusing. I've had a lot of practice since then, but I used to just literally have a function call and then it wouldn't compile. And so I'd change like my ampersand to a star and then compile again and it wouldn't compile. And I would just like kind of randomly make these changes until something ran. And then I was like, okay, don't touch it ever again. Yeah, so we all kind of started there. I've had a lot of practice since then, so, but this might be maybe kind of simple. So yeah, most of you got this correct. This number one, a lot of you picked, this is technically syntactically okay, right? The syntax is fine. You're gonna get a seg fault, but yes, in terms of types, if I dereference a pointer, I can assign it the value in int in this case. But I have not actually initialized I pointer in this particular piece of code. So yeah, the answer is 4. If you've not answered, pick anything at this point and we'll move on. All right. Another simple one. How do we set I to be 50 using the pointer that is pointing to I? Again, just syntax, but it's not just syntax though. It does help you understand once you have a fixed translation in your head, then it's the syntax actually talks to you, you know. You see past all the symbols and you see what's actually happening. All right, so a lot of you, yeah, some picked 2. I mean, this reminds me of, again, when I first learned C. This is what I would do. Try anything. But yeah, this one is correct, right? So I dereference the pointer. When I dereference a pointer, I get back what it's pointing to. So in this case, I would get back an int, and I can do whatever I do with I can substitute I pointer now, dereferenced. So the correct answer is number 3. Feel free to click anything before we go. All right. Given the following code snippet, so now we're looking for what is syntactically correct given these pieces of code. So what type is P? Another way to phrase this, although we haven't used the auto keyword, there is an auto keyword in, sufficiently advanced versions of C++, where the compiler will look at this and assign the correct type to P. So assuming we wrote this with auto, what type is P, I guess, is another question. And a lot of you are saying double pointer, and that is correct because, well, the address of a pointer is a double pointer, right? So, yeah. Again, choose whatever if you haven't chosen anything, and we'll move on. All right. Well, a simple one. We're declaring an array of students. Where are all of these things located in memory? Yeah, as long as your name matches, or even like is pretty close, I'll get it. Yeah. It's if you write your name exactly as it appears in Brightspace, that's perfect. That will work. If you close but not quite, it'll still be okay. I'll have to verify it, but it doesn't take very long. So yeah, where do the students and or array go in this case? Array on the stack, student objects on the stack. That is correct. Everything here is on the stack. This is an array of student objects. Everything's on the stack, just like we did in assignment 1. Again, feel free to click anything before we move on. Are you planning on? Yeah, I should. It is enabled on some of them, just not all of them. I'd have to go through and, which whatever. I have time to do it. I guess I've been lazy up till now. What's this other question? Yeah, that's a good question. I would just call it asset unless there was something else that I thought was more informative, right? But here, this is not. I would just use asset with a small, starting with a lowercase a. It's simple. No, it's not going to deceive anybody, right? But in terms of convention, like, yeah, we have our own conventions, but you would ask wherever you work, they would also have their own conventions. Where in memory do we expect these structures? So what exactly did I do here? I made an array on the heap, and this is an array of student objects. And so yeah, this one, I fooled some people, but it's an array. The arrays on the heap and the student objects are inside the array. So they're also on the heap. In particular, they're definitely not on the stack. You could say that they were inside the array, but so technically number 4 is correct here. Yeah. Again, it's which we're going to take next. It's the rule of least surprise, right? I shouldn't name my variable something that somebody is going to look at and be confused by. So the simplest, easiest, most straightforward thing is often the best. The thing that's not going to surprise anybody, that's what I should name it, right? Because my code is, I mean, obviously, if I write my code correctly, it's going to run on a computer, but the reason code exists the way it does is so that we can read it. And so the people that you work with can also read it. Yeah. All right. So this is, we want a dynamically allocated array of student pointers. Dynamically allocated or on the heap are synonymous, right? So what is the proper syntax to do this? Yeah, well, the majority is correct in this case. So it is the bottom one, right? So we are just, this makes an array of, the type is student pointers, and new subscript means it's going on the heap. Um, I think technically, now I didn't try it out, but in terms of type, this looks syntactically correct. I don't know if the compiler would actually allow you to do this, because this makes a temporary array, but maybe, I don't know. Um, I think that's it. Yeah, that's the last one. All right, so just select anything if you haven't already. Any questions on any of that? All right. Yes, it is similar to malloc in C. In fact, new will, behind the scenes, make a call to malloc, but it also calls the constructor, right? So it calls malloc, you get a piece of memory, and then you call the constructor, which initializes that piece of memory. Right, so it's a malloc and an initializing function in one. All right. There, so that sort of takes us to a lot of the technical details of C++ that we're concerned with when we're using classes. Of course, we're going to get into inheritance and things like that. But we're going to sort of shift our focus a little bit to, so what happens when I sit down, I want to build a piece of software? What should I be thinking about, right? What is software engineering? How do you approach it? What are the best practices? So we're going to talk about that. I'm going to qualify some stuff because, I guess if I'm being completely upfront, software engineering is about processes, right? Right, so what processes do you invoke in order to produce a piece of software? And I believe in programming over processes, right? So I believe that really you should write code, and then you should adopt processes that support you writing code, rather than, I think some people sort of put processes before writing code, which I don't know. That's just my opinion. So if you disagree, that doesn't mean you're wrong. I could be wrong. I don't even think there is a right and wrong. It's just sort of whatever works best for you. But yeah, I like all of these software engineering techniques, I think, are good in the right measure, right? Like a recipe. I add salt to something and it tastes delicious, and then it's a big mistake at that point to like say, well, if a little bit of salt is good, then a lot should be great. And I think software engineering processes are like that. They're excellent in the right measure. Don't let them get in the way of good software. So we're talking about what is software engineering. Yeah, I'm going to have to change the way I mark it, but yeah, you should be fine. I'm going to, if you participated at all, I'm making a promise. I think I can do this. I think WooClap gives me enough information for this. If not, I'll just be a lot looser about how many questions you need for a participation mark. So yeah, what is software engineering? We're going to talk about that. We're going to talk about low-level design. So what should you be thinking about at the low level when you're just actually coding? And then we'll talk about a little bit about high-level design, but that's more of a 3004 subject, right? So you'll get into a lot of that. We'll talk about the workflow, a little bit about testing, but then really, because like I tell you all this stuff, and why should you believe me? So we're going to try and support it with some real-world examples, right? So we're going to look at Unix, Amazon Web Services, and Google, which are three sort of successful software. Well, I don't know. Unix is not a company, but endeavors, I suppose. And we're going to look at what they think, and we're going to try and support the things that we tell you with real-world examples. So what is software engineering? It is a set of processes, best practices, strategies, design patterns used to deliver high-quality software, arguably. What is high quality software? Well, code that's reliable. I mean, this is number one, right? Customers like it when your software works, and they hate it when it doesn't work. That's a sort of universal truth. But beyond that, we want to be able to add features and not go to a lot of trouble to do that, right? Reusable, I mean, if you're making a library, and scalable, right? If you want to be successful, well, there's a big difference between 100 customers and 1,000,000 customers, right? So that's, even though it's technically the same code, it's got to run a lot better. So yeah. That's fine. I mean, I'm going to do a lot of, if you think you got an unfair WooClap mark, just email me and explain your situation, right? This is not, the WooClap are just meant to encourage participation. So I'm not, you know, I'm not going to be super strict about who gets what, you know, make sure that, oh, you don't get that mark unless you absolutely deserve it. Like, no, there's a lot of flexibility there. So just email me if you don't think your mark is fair. So yeah, writing code that works and correct is the most important thing, right? You can't, the customers don't buy broken code. Customers don't buy documentation for an app that doesn't exist. And they don't buy test suites, right? They only buy the code that works. But once you have working code, you should be considering other aspects of your design. You want to be able to make updates and extensions easy as possible. And that typically requires modular code. I'm going to separate concerns. I'm going to have subsystems that take care of certain things, and those are going to be separated by clearly defined interfaces or APIs, right? So that's why all of this access modifiers and things like that. So what we really want to produce modular code, we're going to use encapsulation and abstraction. These are kind of the same idea. We're going to hide unnecessary details, but we're going to hide them behind a general interface. So for example, when I say open a file in C++ or whatever language, like there's a lot happening, right? There's a lot of like low-level code that's being run. There's a lot of details that you don't really care about. And that's abstraction. That's like, okay, I don't need to know how my SSD works. I just need to be able to open a file on it and write data and read data from it. All right, so that's abstraction and encapsulation. And one of the ways that we're going to achieve those two things is using the principle of least privilege. We don't make anything public unless we absolutely have to. So we're going to, that's going to help us keep our code encapsulated. It's going to help us hide unnecessary details. Anything you make public will get used by somebody. So then once you make it public, it's too late. It's got to stay that way forever, essentially. All right, so yeah, encapsulation and abstraction. I mean, I used to give different definitions, but it's such a minor difference. I think they really sort of belong together. Essentially, we're hiding implementation details behind a general interface. That's the whole thing, really. But it's helpful, right? We use abstraction not just in programming, but everywhere, right? I say, like, I'm going to drive to your house. Well, I don't say I'm going to drive down like a Hunt Club and then turn right on Riverside. I don't give you all those details. I just give you the abstraction. And I manage the details. So that's keeps our code simple, reduces cognitive load, makes it easy to use libraries. And yeah, and then as you'll see, we'll be able to add features without changing the central algorithm. The principle of least privilege helps us to achieve proper encapsulation. So again, your objects should be as introverted as possible. Don't expose anything you don't have to. All right, so that's low level. High level design, what sort of architecture are you going to use? That's 3004, again, mostly, but you know, there's a lot of pre-existing designs, and you will bump into them when you're making things. And especially with large language models, because what happens is If you, for instance, try to build a web server that does X, well, it knows 1,000 examples of web servers that do X, and it's going to kind of push you into a design. And those designs are usually pretty good, actually, I find. So yeah, there's a bunch of pre-existing designs you can kind of select from. At some point, you may have to start implementing your own design on stuff that's new, but and yeah, I mean, the over-design trap is a real thing, right? So don't build a bunch of stuff you don't need, but it's easy to fall into. A good workflow for a typical, basically any company, you're going to have some sort of requirements analysis. Not even any company. If I'm going to write a piece of software, I'm thinking, how is this going to be used? And so what has to happen when a user sits down and interacts with it? And that brings up use cases. At which point I want to try and come up with a design and an implementation. Now, design can be very complicated, as in a lot of documentation, like you'll do in 3004, or it can be a very simple sketch on a whiteboard, or it can be all in your mind. All of those are fine. And then you want to try and then you start coding, right? Once you have written something that seems to work, test it, and then repeat, essentially. So this workflow works for very simple cases, just you sitting at home, or like you working at Google. These are the same basic steps in both cases. Array constructors for strings, we should use string copy. Oh, string copy is a C. That's a C function, eh? You shouldn't. I mean, use the assignment. I don't know, string copy may work on C++ strings. I kind of doubt it, but maybe, I don't know. So yeah, just use the assignment operator. All right. Yeah, well, C strings are not the same as C++ strings. They are wildly different. C strings are very simple things. All right. So yeah, this is my own experience. Think of the feature you want to build it. Really, at this point, I avoid any type of design pattern or best practices, right? Because now if I'm using design patterns, these are just more places where bugs can be. So I keep it as simple as possible. I just get it working, and then when it's working, then I extract the design and refactor and do all those things. So that's what I find works, but again, it's up to you. I don't know. Build stuff and find out. I think it's really important not to get bogged down in processes. Just build things, and these things will all become clear to you. I think I'm going to stop there today. But yeah, I'll leave you with this. You can just do things, right? Just build, see what happens. That's the most important thing. It's not that this stuff is not important, but you can learn a lot of it just by applying yourself. All right, so that's it for today. Yeah, we'll continue with this next class. Yeah, well, strings in C++ are they're a class, eh? So they're like a C string but wrapped in a class. We're going to sort of do something similar when we wrap our arrays in a class and make so that we don't have to do all this low-level stuff anymore. So there is a lot of like conversions between C strings and C++ strings, and a lot of them happen implicitly, but you can't guarantee that they always work the same. Yeah, probably a good idea. Hey.